We have already implemented the player's control. But the player disappeared from sight after walking away. In the actual game, should have the camera follow the player. But before achieving this, you must have the necessary mathematical foundation, including vectors and vector operations, Euler angle quaternion difference operation, etc. This lesson, let's learn about the math in the game together. Vector Euler angle quaternion difference operation. So let's start with vectors. In SandMod games, usually we use vectors to represent the position of objects and rotation information. So we need to know the coordinate representation of the space vector. For example, in this picture, vector equals xyz. In a spatial coordinate system, the starting point is the coordinate origin. A vector with an endpoint of P. The coordinates of point T are x, y, z. Certainly, it can also be expressed as a matrix. This is what it looks like. The most basic. You need to understand the meaning of the modulus of the vector. When we talked about vector conversion before, yes. You also need to know about vector addition and subtraction. This is in high school math. You know the geometry of vector addition and subtraction. That's it. Put it in actual calculation. There already made a PIS in the engine that can be called. Vectors in the game is often used to describe the positional relationship between objects and direction of motion. And in the game, rotation of an object is usually expressed by the Euler angle. Let's go to point Euler. Euler point. It is one of the ways to characterize the rotation of the cylinder. Three angles introduced by Leonhard Euler. Used to describe a cylinder block, direction relative to a fixed coordinate system. In photogrammetry, space science, or other technical fields. Usually a set of three Euler angles is used. Describe rotation transformation relationship between two spatial coordinates. A rotation of a steel body in three-dimensional space. The angle that can be rotated about the x-axis. The angle of rotation around the y-axis. The angle of rotation about the z-axis is represented by these three angles: roll angle, pitch angle, heading angle. or use the symbols alpha, beta, and gamma. Represents roll pitch and heading around the XYZ axis respectively. Angle of rotation. The sign of the three corners can be represented by the right-hand rule. Clockwise is positive. But due to the deadlock problem of the universal joint at the Euler angle, and in programming it's hard to avoid thinking. So now we're using quaternions more. Attitude, representation, and rotation. So let's look at quaternions. 1843, Irish mathematician Hamilton invented quaternions. Supernegative numbers of this form. He also gave the addition of quaternions. The rule of multiplication and the inverse clamping of quaternions. Point out that quaternions can be rotated by transformations such as elongation or shortening. Transform a given vector into another vector. In the expression of tetraprimal numbers, Q0, Q1, Q2, Q3 is any real number. IJK is an imaginary unit. Where Q0 plus Q1 I plus Q2 J plus Q3 K is the algebraic form of a quaternion. Q0 is the 10 steps of the quaternion. K plus Qr J plus Q3 K is the imaginary part of the quaternion. For the geometric meaning of IJK itself can be understood as a kind of rotation. Where I rotates represents the plane where the z-axis and the y-axis intersect. Z-axis forward rotation, y-axis forward rotation. G-rotation represents the plane where the x-axis and z-axis intersect. X-axis forward rotation, z-axis forward rotation. K-rotation represents the plane where the y-axis and the x-axis intersect. Y-axis forward, x-axis forward rotation. EJK stands for EK rotation respectively. the reverse rotation of. Compare this to the picture above. It is easy to draw the following conclusions. IR equals JR equals KRE. JKKJ equals I. KIK equals J. EG equals K. Quaternions are currently used for high-resolution optical remote sensing, satellite. Common attitude parameters for on-orbit attitude measurement and control. Mode of expression. There is no starting point. Expression is unique. Therefore, for elements are also commonly used in Sandy games. So, in the actual programming process, how are quaternions used? We need to understand quaternions and Euler angles, and the equivalent transformation between rotation matrices. Quaternion and rotation matrix transformation. Adopt this formula. The transformation from Euler's angle to quaternion uses this formula. Quaternion to Euler angle. Adopt this formula. These formulas don't need to be memorized either. You just need to know. Quaternions represent rotations in three-dimensional space. Know to take advantage of the ready-made API provided in the engine. Understand these formulas. You won't be torn. How is the underlying API implemented? Below. Let's take a look. API for quaternions in our game engine. For example, here are some commonly used methods in quaternary arts. The first method is the bottom layer. It's a formula we just talked about. You can understand. There is a difference method in the quaternion method just now. Here we give you a brief introduction. Difference operation. The essence of the difference is to turn discrete data into a continuous curve. Difference operations are often used for data quasi-kernels, image processing, motion control, etc. These are the two animations that you're looking at. This is the quadratic curve difference and the principle of cubic curve difference. Suppose the player moves quickly from P0 to P1. Move to point PR. Camera follow. Time. In order to make the shooting effect too smooth, difference arithmetic can be used. After the final difference, the camera follows the red trajectory. More about the difference algorithm. Interested students can find out after class. We're here to talk about difference arithmetic. The purpose is to hope that everyone understanding the role of differences. How is the underlying API implemented? When calling the engine API-related methods, just don't be confused. This lesson, we popularized some in-game math. For example, vector Euler angle quaternions, difference operation. At this stage, everyone has a preliminary understanding. In the next lesson, we're going to look at the character's camera following.